Hello everyone, I'm Monica. Today I'd like to introduce to you NG MVPN, a multicast technique. As the demand for services such as IPTV and video conferencing increases, ISPs are now faced with the challenge of how to better provide these services on existing networks. BGP or MPLS VPN is being widely deployed on carriers' networks. Using legacy networks to bear multicast services such as IPTV and video conferencing is able to handily meet multicast service requirements for bandwidth guarantee, security, scalability, and reliability. It also reduces the deployment cost for carriers. The technique of using BGP or MPLS VPN networks to bear multicast services is called multicast VPN, MVPN. Early on in its deployment, Rosen MVPN was the form MVPN most commonly took. Rosen MVPN controls multicast protocol and data packet forwarding by using PIM on the public network and by setting up a dedicated full-mesh multicast distribution tree on each PE of an MVPN. Therefore, Rosen MVPN is difficult to configure and maintain. Rosen MVPN uses GRE to encapsulate multicast data and can therefore use only GRE tunnels to transmit the data, making it incapable of leveraging the known advantages of MPLS. To address the preceding issues, next-generation MVPN, NG MVPN, was introduced. NG MVPN uses BGP update messages on the public network to transmit multicast VPN protocol packets and multicast VPN routes, simplifying deployment and maintenance. NG MVPN also uses sophisticated MPLS tunneling and protection techniques to improve the quality and reliability of multicast services. Meanwhile, NG MVPN itself provides effective network protection solutions to improve network reliability. NG MVPN is implemented through 4 main steps: automatic discovery of MVPN members, MPLS VPN tunnel establishment, multicast group joining and leaving, and multicast VPN route transmission. Step 1. PEs on the same MVPN announce their existence through BGP messages so that they can discover each other and establish peer relationships with each other. Step 2. The PEs establish MPLS P2MP VPN tunnels to bear multicast data. Step 3. A user sends a join or leave message to a CE. The CE adds the user to or deletes the user from the multicast group, converts the message, and then transmits the message to the upstream node to create or delete multicast VPN route. Step 4. PEs on the same MVPN use BGP update messages to exchange multicast VPN multicast routes, determining the routes used to forward multicast data. NG MVPN supports various reliability protection schemes, such as MPLS TEFRR for MVPN tunnels. If the link between the ingress and egress of a tunnel fails, the backup path established by TEFRR can rapidly take over traffic to implement MVPN protection. NG MVPN itself also provides reliability protection schemes, such as dual route 1+1 protection. To implement dual route 1+1 protection, deploy 2 sender PEs on the same MVPN to establish 2 tunnels, 1 primary and 1 backup, to the same receiver PE. In addition, configure BFD to detect node or link faults on the tunnels. The receiver PE receives 2 copies of the same multicast traffic from both the primary and backup tunnels, but the receiver PE discards the copy received from the backup tunnel. However, if the primary link fails, the receiver PE rapidly detects the failure using BFD and permits the copy received from the backup tunnel. Because NG MVPN has the preceding advantages, it is very suitable for carriers aiming to provide IPTV services for users. NG MVPN can also be used to bear video conferencing, video on demand, VOD, and real-time network game services. Thank you for watching. Goodbye.